In this activity, we are going to fold paper and make triangles and then classify the triangles based on angles and sides. Take a paper, put the colored side up and then fold it such that this bottom vertex meets the top vertex. You can see we have made the first triangle. Let me explain this triangle, and from the next time onwards you are the ones who are going to tell the classification. Let me explain how you will do the classification of the triangle. First, look at all the angles. In this triangle, this angle matches with the corner of a square. So it's a right angle triangle because we have one right angle. Now let's classify it based on sides. Two sides of this triangle are the sides of our original square. So they are equal. So in this triangle, two sides are equal. And this is a longer side. So this is an isosceles triangle based on sides. So the classification is based on angles, right angle triangle, and based on sides, isosceles. Now as we fold, you have to do the classification. For the next step, fold this side to meet this edge. Can you see we have made 3 new triangles? Identify these triangles based on angles and sides. Let's look at triangle 1. Triangle 1 has a right angle. So based on angles, it's a right angle triangle. Now let's look at the sides. It looks as if this side is equal to this side. Can you see? You can turn and check like this. So these two sides are equal. Clearly this side is bigger. So based on sides, two sides equal means it's an isosceles triangle. Let's look at triangle 2. Can you see? This is the corner of our square. So it's a 90 degrees. Let's check it with this small square. Yes. That means triangle 2 is also a right angle triangle. Based on sides, let's check if these two sides are equal. You can just gently fold and check. You can see they are not equal. All sides have different lengths. So 2 is a scalene triangle based on sides. For triangle 3, again, one angle is 90 degrees, means it's a right angle triangle. And 3 sides are unequal, so it's a scalene triangle. Let's continue with our folding. Turn this model over and then make this vertex meet this vertex along the edges. So you are going to fold it such that now can you see there is a flap over here? You have to put your finger in the flap like this and fold such that this meets this edge. Now we have 2 new triangles, 4 and 5. Can you identify what kinds of triangles are these? To identify this, Let's check this angle. Can you see when you put a square, this angle is more than 90 degrees. Means it is an obtuse angle. So this is an obtuse angle triangle. The lengths are unequal, so it's a scalene triangle. Let's check 5. 5 is also an obtuse angle over here. It means that this is also an obtuse angle triangle. 5 is an obtuse angle triangle, and since the sides are unequal, it's a scalene triangle based on sides. Place one hand like this and turn this model. We go back to a right isosceles triangle. Now you have to fold it in such a way that this side meets this edge. Fold it like this. This meets this. Can you see we have 3 new triangles, 6, 7 and 8. Can you identify these triangles based on angles and sides? Triangle 6 is a right angle triangle. Let us see if it is isosceles also. Turn this and check the length. Can you see? These two sides are equal. Means it's an isosceles right triangle. At triangle 7. This very clearly looks obtuse. But let's check. Can you see? The angle is much more than 90. So this is an obtuse angle triangle based on angles. From sides, we need to check whether this length is equal to this. You can lift the model and fold it and try to check. Can you see the lengths match exactly? If two lengths are equal, it's an isosceles triangle. So this is an obtuse isosceles triangle, triangle 7. What about triangle 8? Look at the angle over here. It is obtuse. Check it. It's more than 90.
Look at the sides. They are unequal. This means it's a scalene triangle. Now fold the other side as well. So we will get two sets of triangles 7 and 8. Fold it carefully and then fold it in the middle like this. Lift it and fold. You will see now a new set of triangles. Can you see the white part over here? This white triangle is the next place where we need to fold. Fold this edge to meet the other. So we are bisecting that white angle. This edge needs to be folded on to this edge. Can you see we have got 5 new triangles? Let's number them 9, 10, 11, 12 and 13. Can you identify each triangle and classify it based on angle and side? Let's look at triangle 9. Looks like an obtuse. Let's check. Yes, this angle is more than 90. And the sides are all unequal. So it's an obtuse scalene. What about 10? Looks like an acute angle triangle. All angles are acute. What about from sides? Can you check? Looks like an isosceles acute triangle. Use your scale and find out. What about 11? This looks like a right angle triangle to me, but let's check. Yes, can you see this is a right angle? Now let's classify it based on sides. Is it isosceles? Let's check. These two sides look equal. Yes, they are. So it's an isosceles right triangle. Now we are left with 12 and 13. Now if you fold 12 on 13, can you see they match exactly? Such triangles are called congruent triangles. So once we find the classification for one, we get for the other because they are exactly the same. Now 12 looks like an obtuse angle triangle. Let's check. Yes, the angle is more than 90. The sides all look unequal. So it's an obtuse scalene. So 13 is also obtuse scalene. Now let's continue our folding. Fold this triangle down onto triangle 13. Okay. And now you'll see many flaps over here. Lift a single flap. Okay. Only the top flap which is colored. And push the triangle 12 back again into its original position. Whatever previous folds we had made on the same folds, just fold it back again. Can you see? Let me show once again. Okay. This is how your triangle 12 was. Push it so that it falls on triangle 13. Now lift a single flap. Okay, there are many sheets there. A single flap and then put the triangle 12 back in its original position. The same folds which were there before we used, and then push this flap down. See the triangle 10 has become bigger. Now turn the model over and this bottom side of the white triangle has to be folded onto the top side. You're going to bisect this angle. Okay, fold it this way and now you will get a new triangle. Make sure you fold crease hard. Now open it and like we did in the previous side, take a single flap and then fold the triangle in again. Like before, we are not going to make any new creases. The same creases will be reused. Just fold it. This is how your model will look. Now we are going to make a triangle on this side. Any triangle of your choice. Just fold it so that you form a triangle. See, this is the way I have folded it. Now you have to fold it on the same crease on the other side also. Turn the model around and on the fold that you had made before, fold it on this side. Okay, just turn it on this side. Now lift the model, slightly open it, and those folds that you had made, it will look like a V. Gently push this part which is up inside. You see, use your finger and press it in. You are going to fold on the same folds, but push that paper inside gently. This forms a beak. And you can see we have a new triangle ready for us. Mine is obtuse. What is yours? See this, that one. Now let's look at the lower section. In this triangle, you are going to make this side of the triangle fold along this line. Lift it and fold it so that one side of the triangle is in line with that edge. This is an obtuse scalene triangle. See, this side is folded so that it is in line with that. And you get a triangle. Turn it over. Repeat. Make this side fold along that edge. This way. Again one more obtuse scalene triangle. Can you see? All these triangles have helped us build some model. Make it stand. Can you tell what this is?